Okay, algebra part 3, quadratic equations, sum and the product of the roots of quadratic equations. This is part 1, talks about sum and the product. First, what is quadratic equation in general? It is in the form of ax squared plus bx plus c equal to 0, where always a not equal to 0, otherwise it will not be quadratic, it will be linear. If a equal to 0, then what left is bx plus c equal to 0, then it is a linear equation and not quadratic equation. First, if the roots exist, if roots exist means if delta is greater or equal to 0, because if delta negative, roots not exist. If delta positive and delta equals 0, we have roots. If roots exist, this implies that what do we have? We have two roots, right? If delta greater or equal 0, we have two roots, alpha and beta. Alpha is minus b minus radical delta over 2a, and beta is minus b plus radical delta over 2a. What are the sum of the roots? Sum of the roots, we add them, it's alpha plus beta, so it is equal to minus b minus radical delta over 2a, this is alpha, plus beta minus b plus radical delta over 2a. Since they have same denominator, we can add them. Minus radical delta plus radical delta is 0. Minus b and minus b, it's minus 2b, right, over 2a. So the answer will be minus b over a. And this is the sum of the roots of quadratic equation if the roots exist, if delta is greater or equal to 0. And what is the product? Product is equal alpha times beta, which is equal to minus b minus radical delta over 2a into minus b plus radical delta over 2a. We multiply the numerators. It will be minus b minus radical delta into minus b plus radical delta. This is difference of the square, so it's minus b all square. It will be b square minus radical delta all square. It will be delta over 2a times 2a, which is 4a square, which is equal to b square. What is delta? Delta is equal to b square minus 4ac. So what is minus delta over here? Minus delta, this means that minus delta, this means I'm multiplying the minus b square minus 4ac, all of it with minus, that will be equal minus b square plus 4ac, right? So it's minus b square plus 4ac. This is minus delta over 4a square. B square minus b square, we cancel them. What left is 4ac. B square minus b square is 0. 4 divided by 4. What left is 4ac, right? 4ac over 4a square. Now we can cancel. 4 divided by 4 cancel. And a over a. So what left is c over a. And that is the product. So the sum is minus b over a, that we found it up here. And the product is c over a. That's great. So when the roots exist, those are the sum and the product. Let's try to write a form of quadratic equation in terms of sum and the product. We said that any quadratic equation is of the form ax squared plus bx plus c equals 0 for sure, where a not equal to 0. Always we have to know that a should not equal to 0. Let us divide both sides by a, all terms by a. Since we have 0, a over a cancel, it's x squared plus b over a, x plus c over a equal to 0. This implies that we can write it in the form of x squared minus into minus b over a times x. Minus times minus is plus b over a. Why I'm doing that? To show you how to write the quadratic equation in the form of sum and the product. X squared is x squared minus the other minus b over a. This minus b over a is the sum. We found that the sum is always equal to minus b over a, right? So it's minus sum times x plus, what is c over a? C over a is this one here, which is the product, equal to 0. This is the quadratic equation written in terms of sum and product. That's great. Now, let's see if we can find delta, right? From this equation here, if we want to find delta, which is b square minus 4ac, this is b. When we square it, it's s square minus 4 times a, which is 1, times c, which is p. So delta can be written also in this form, s square minus 4p. So again, delta can be written b square minus 4ac if we have a, b, and c, and delta can be written in the form of s square minus 4p, and s and p represents the minus b over a and the c over a when roots exist, so this will be greater or equal to 0. Otherwise, s will be equal to minus b over a, but not, and p is equal to c over a, but they don't represent the sum and the product, because sum and the product of the roots should be there. Delta shouldn't be negative. Let's take an example. We still have time. We can do one of the examples. Suppose we have equation minus x squared, right? Minus x squared plus 3x plus 4 equal to 0. Suppose this equation has two distinct roots. It's given that it has two distinct, two different roots, right? What are the two distinct roots? Find their sum and the product. We have to prove that, this equation, this quadratic equation, has two distinct roots, and if it has two distinct roots, find their sum and the product. Find their sum and product. We have to find the sum and the product of these two distinct roots. Product, C. Okay, how can we find that it has two distinct roots? First, we should find delta, right? What is delta equals to if we have a, b, and c? B squared minus 4ac, right? Let's first find a, b, and c. Designate a, b, and c. A is equal to what? The coefficient of x squared, which is minus 1. B is the coefficient of x, which is 3, and c is equal to 4, the constant coefficient, right? Which is not multiplied with any x, or x to the power 0. What is b squared minus 4ac now? This is b squared minus 4 times a, which is minus 1, times c, which is 4. The answer is 9. Minus times minus is plus. 4 times 1 times 4 is 16. The answer is 25. Since delta is greater than 0, yes, roots exist. Not only that, two distinct means different, not equal, real roots. Two distinct and real roots, right? We don't have to find the roots. Without finding the roots, we should know their sum and their product. This is very nice because it's simple now. Sum is equal minus b over a, right? We have b is 3, minus b is minus 3. Over a, we have a, which is minus 1, so the sum is equal to 3. And product is equal to c over a, so it is equal. C is equal to 4, a is equal to minus 1, as you can see here. So the answer is minus 4. So we found sum and product. And again, you have to be careful. We cannot find the sum and the product if we don't make sure first that the roots exist. And the roots, to make sure the roots exist, we have to find delta. And delta should be either positive or equal to 0. And see you in the next example to continue with sum and the product in another video.